So you've probably heard of 3D printing, right? Maybe you've even seen one of those little desktop machines printing out a plastic keychain. But, that's really just the tip of the iceberg. Today, we are going way beyond the hobbyist desk. We're going to explore the industrial scale revolution that is changing, well, pretty much how everything is made. So let's dive in.
To really get where we're going, we first have to understand the two basic ways you can make anything. For, centuries, we've done it one way: subtractive manufacturing. Think about carving a statue. You start with a big block of marble and you chip away everything that isn't the statue. But what if you did the exact opposite? What if you started with nothing at all and you built the statue up little by little, like you would with clay? And that simple idea, that's what we're talking about today.
And that's where this big term comes in: additive manufacturing, or just AM for short. It's really the industrial version of that building up philosophy. The official definition is creating an object by adding material, layer by painstaking layer. So instead of removing material, you're always adding it. It sounds simple, but that one little shift in thinking just unlocks a whole new universe of possibilities for design and engineering.
Okay, but here's where it gets really interesting. Additive manufacturing isn't just one technology. Not at all. It's a whole family of different technologies, and each one has its own special way of adding those layers. You can kind of think of it like a family tree with 7 main branches. And here they are, all 7 official categories. Now I know, it looks like a lot to take in at once, but don't worry about memorizing them all. You can really think of them in a few main groups. Some of them work by melting powders or wires with lasers, some use light to harden liquid resins, and others even laminate super thin sheets of material together. The key takeaway is that each method is perfectly suited for different materials and different jobs, from making massive parts for airplanes to creating unbelievably tiny medical devices.
So, we've got these two totally opposite ways of thinking, right? Adding material or taking it away. It's one or the other. But what if you didn't have to choose? Let's take a look at a technology that asks that exact question. First up, let's talk about the strengths of additive. Because you're building from the ground up, you can create these incredibly complex shapes inside of other shapes, things that would be totally impossible to do with a drill or a carving tool. You can also lay down material really fast and you waste almost nothing. It's all about total design freedom and being super efficient. Okay, now for the other side of the coin, subtractive. Your traditional CNC machining. Where computer-controlled tools carve away material, that is the absolute king of precision. It can give you incredible accuracy and that perfectly smooth, mirror-like finish. It's the tried-and-true method that industry has relied on for decades. Its strength is all in that final, perfect detail.
And here it is, the big what-if moment. What if you could have the insane design freedom and the material efficiency of additive, and the pinpoint accuracy and perfect finish of subtractive, all happening at the same time?
Well, that is the absolute genius behind hybrid manufacturing systems. They combine laser-based additive processes with CNC machining inside a single machine, so you can build up a complex part layer by layer, and then in the very next second, a cutting tool can come in and machine that surface to a perfect finish. You add some material, you machine it down, add some more, machine it again. It's a total done-in-one solution, and it's a total game changer for making complex, high-quality parts.
Okay, so we've seen how these hybrid systems can combine brute force with fine detail, usually with metals. But to really show you the sheer range of what AM can do, we're going to do a complete 180. We're pivoting from metal to liquid and from huge parts to microscopic ones. Let's explore something that feels a little less like engineering and a little more like magic. We're talking about printing with light.
This quote from Kurt Vonnegut just hits the nail on the head here. Because when you see this next process, it's called vat photopolymerization, or VPP, it honestly looks like magic. It really looks like you are pulling a solid object right out of a pool of liquid.
So how does this magic actually work? Well, as you can see, VPP is part of the polymer family of AM. The basic idea is simple, but honestly, it's brilliant. You have a vat, a tub of the special liquid resin. It's called a photopolymer, and it's designed to harden instantly when you shine a specific kind of light on it. Then you just use a controlled light source, like a UV laser or a projector, to trace the shape of one layer. It hardens, and you just do it again and again.
The whole thing is basically a 4-step dance. First, a flash of UV light cures a super thin layer of resin. Second, the machine puts a fresh, new layer of liquid right on top. Then, once the whole part is built up, step 3 is just giving it a good clean to get rid of any sticky, uncured liquid.
And finally, step 4, it gets a little spot treatment. It's post-cured with more light and heat to lock in its final strength and make it super tough. It's an incredibly controlled and precise sequence.
So what do you get for all that precision? You get this. It's incredible. On the left, that little thing is a soft robot gripper, tiny enough to pick up a single screw. And that lattice on the right, the details there are so fine they're measured in micrometers. We're talking way smaller than a human hair. This isn't just manufacturing anymore. This is microfabrication. It's opening up whole new worlds in medicine, robotics, you name it.
So we've seen some absolutely wild technology, from giant hybrid machines to things printed with light. But the biggest thing shaping the future of AM, well, it might not be a technology at all. It might just be a philosophy.
This quote really gets to a major roadblock the field has faced. For a long, long time, the growth of these amazing technologies was actually held back because they were all locked up in proprietary closed systems. It was like buying a car, but the hood was welded shut. It really slowed down progress because researchers couldn't get in there and tinker, experiment, and push the boundaries of what was really possible.
But now, there's a powerful alternative taking hold, the Open Additive Manufacturing Initiative. It's a move towards open-source platforms, giving everyone the keys to the car. These systems give users full access and full control, so the entire scientific community can collaborate, share what they learn, and accelerate progress together. It's all about unlocking the technology's true potential.
So where does all this leave us? We've gone from massive machines that build and carve to microscopic parts printed with light. We are fundamentally redefining what it even means to build something. And that leaves us with one really big, profound question. When our tools no longer limit our imagination, what in the world are we going to create next?